Sketch the graph of y equals x minus 2 cubed plus 1, clearly labelling any axial intercepts and the point of inflection with their coordinates. So when the graph is in this form, we know that the point of inflection occurs when x minus 2 equals 0, so that gives x equals 2, and y equals 1. Therefore, the coordinates of that point is 2, 1. Next, we can determine the y-intercept of this graph by letting x equal 0. So when x is equal to 0, we find y is equal to 0 minus 2 cubed plus 1. So y equals, and now negative 2 cubed gives negative 8 plus 1, which equals negative 7. So the coordinate of the y-intercept is 0, negative 7. Finally, we can work out what the x-intercepts of this graph are, and that happens when y equals 0. So we will have 0 is equal to x minus 2 cubed plus 1. Subtracting 1 from both sides of the equation gives x minus 2 cubed equaling negative 1. Therefore, we find that x minus 2 is equal to the cubed root of negative 1. Then we can add 2 to both sides of this equation to find x by itself. And that will give x is equal to the cubed root of negative 1, which is negative 1, plus 2, which equals 1. Therefore, the coordinates of the x-intercept is 1, 0. With the information that this is going to be a positive cubic, because there is no negative symbol out the front of the x cubed term, we know that the general shape will be something like this, where the y-intercept was at 0, negative 7, the x-intercept was at 1, 0, and the point of inflection was at 2, 1. On this slide, we've got a computer to generate this graph, so it's a little bit more accurate than what our by hand sketch was, but we can see that all the key features have the same coordinates and that we have a positive cubic shape going through those 3 points.